Hello everyone, and welcome to this fifth video of the course, Energy and its Utilization. In the previous lessons, we have discovered what energy is and what its different manifestations are. We have also learned the difference between energy and power, as well as the application of these concepts in the electrical field. Subsequently, Milano, we continued with a chronological review of how our use of energy has evolved throughout history, leading to the progressive electrification of energy consumption. We also saw what different sources we have at our disposal to obtain energy, both renewable and non-renewable. And painina in the CERN, alikakat kutis faiti. Now in this video, we will take up the baton from that contextualization to start defining purely electrical concepts, their role in the recent history of science, and their implications for the present and future of our electrical systems. Today, gentlemen, we will talk about alternating current and direct current. Of course, to talk about alternating current and direct current, it will first be necessary to define them. The first step is to know what electricity is. We could define it as that set of phenomena that occur from the excitation and interaction of the electric charges that make up any body. And these charges can be both positive and negative. The existence of electricity has been known since the year 585 before Christ. It was then that the Greek philosopher Thales of Miletus observed the triboelectric effect in a piece of amber. This effect explains that by rubbing one object with another, static electricity appears. In the case of Thales of Miletus, he discovered it by rubbing amber with animal skin. He could perceive how the amber became charged with static electricity and then began to attract feathers, hair, and other lightweight objects. We can also observe the triboelectric effect in our daily lives, or we can perceive it for example, when our hair stands on end when we rub against a balloon, or when we get close to the screen of an old turned-on television. We can also feel it when we wear a synthetic sweater and the friction of its fibers with our body causes us to become charged with static electricity. With a mismo subaran amnaninasi. Then if when we touch someone, and we will feel that unpleasant jolt of a shock that happens because we are discharging our static electricity through that person to the earth. In fact, this discovery by Thales of Miletus is what gave electricity its name. It comes from the classical Greek electrons, which is a third electron, which means amber. Electricity itself can manifest in different ways, and Thales of Miletus had discovered one of them. But it took much longer to understand in detail the nature of this useful manifestation of energy, and also to be able to take advantage of it. One of the issues that will define the uses we can make of electricity and the technologies needed to work with it is the way it flows. And with this, we already have the door open to the great distinction. How does electricity flow? We have direct current and alternating current. The first case, direct current, is what you find in batteries. On them, we have always seen a little plus symbol and a little minus symbol marked, which specified exactly how we should place the battery in the remote control, in the Game Boy, which I don't even know if it's still used, etc. But this ultimately indicated directly a polarity for its connection. It's not just a physical matter of how I place it geometrically, but it indicated that polarity, and ultimately it is that polarity that will determine the direction of the current flow. In this case, let's not forget, it is direct current. We will have a single direction. Thus current will flow continuously with the same intensity and in a single direction. And this happens because at the ends of the wire through which it flows, there will be a difference in charges caused by the battery. In one place, we will have an accumulation of negative charges, and in the other, there will be a deficiency of negative charges or an accumulation of positive charge. So the electrons will tend to flow from where there are more negative charges to where there are fewer to balance the system. But this has not always been believed. In the past, it was believed that the direction was the opposite, and it has finally been standardized this way among scientists and engineers. Regardless of the actual physical phenomenon, in circuits it is conventionally represented that the current flows from positive to negative. But regardless of all this, we see that the direction of the current flow will be one. It will be continuous. That is the nuance that interests me. The second case is that of alternating current, which is what reaches the outlets in our homes. In alternating current, the direction in which it moves will alternate. First, it will flow forward, and then it will flow backward. And this is because the source that generates it will vary its polarity in such a way that it determines when the current flows in one direction or the other. This change of polarity will be defined by a sinusoidal wave, uextala kuna amerindenanta o sinusoidal wave, in which it can be perfectly observed how the electrons flow in one direction or the other, depending on the values that this wave takes, positive or negative. And the number of times that change occurs is what we call electrical frequency. We have already seen what direct current is and what alternating current is. Now, when we observe high voltage lines or the distribution of electricity throughout our electrical system, we see that electrical grids are fundamentally designed in alternating current. And one might ask, why? What are any of the reasons for this apparent dominance of alternating current over direct current? This is a question whose answer has not always been so clear and was what led to the well-known war of the currents between the Americans Thomas Alva Edison and George Westinghouse as major entrepreneurs, let's say. Although there were many other very relevant figures around these two, here I summarize that episode of history. Edison founded Edison Electric to develop and implement direct current as a way to generate transport and consume electricity. He joined forces with the magnate J.P. Morgan, and they managed to create the first direct current power plant to supply a district of Manhattan. It was then that it began to be seen that electricity could be the perfect substitute for gas in home heating and lighting. Of course, this arouses the interest of another giant of technology, George Westinghouse, who dominated gas distribution in the United States. It was clear that his gas business was threatened by electricity, and he wanted to enter this new market, but not with direct current, as he thought it was an inefficient technology for transporting electricity. He would bet on alternating current. Here would begin the great race for dominance in the electric sector. Whoever gained control with their technology would be the one to establish the standard for the country's entire electrical grid, something like what happened between DVDs and Laserdiscs. In the end, DVDs won and became dominant worldwide. That's how standard worked. And here we were seeing how the alternating current standard competed with the direct current standard. Westinghouse pirariganta kamisanta with alternating current biarbita kanyasagete managed to light up Massachusetts. Later, he continued gaining dominance over other cities, imposing his technical arguments against those of Edison. On the other hand, Edison did the same, ukasi Iris and Masib, and thus each one took control of different groups of cities in the United States that decided to bet on one technology or the other, waiting to see which one would prevail. All this becomes quite complex and turns into a fierce commercial battle. The main drawback of the Westinghouse system was that it managed to light bulbs with alternating current, but it had not yet succeeded in creating a successful system to produce movement, motive power. Edison had indeed achieved this, and although direct current was less efficient for energy transmission because it could not use high voltage, this specific aspect made him a strong candidate. He could produce light and movement. Finally, Westinghouse allied with Nikola Tesla to obtain his patents for the alternating current motor and to be able to produce motive power from this type of current. This would catapult as technology, so finally, alternating current prevailed, consolidating with the lighting of the Chicago World's Fair in 1893. Alternating current power plants were built, such as the Niagara hydroelectric plant, and the world as we know it today was constructed. Thus, we have inherited an electrical system that predominantly operates using alternating current. But let's not be mistaken, direct current also plays a fundamental role in our current relationship with electricity. On one hand, from the consumption side, our electronic devices all operate with direct current. The computer, the phone, the television are all clear examples that although they are powered by the alternating current electricity that reaches our outlet, have a power supply responsible for adapting the voltage level and also the type of current. Thus, we are able to reduce the voltage required by these devices and at the same time convert the direct current from the alternating current we receive. On the other hand, direct current is also increasingly being used in our electrical systems for electricity transmission. We saw that as the main drawback of direct current is that it does not allow the use of transformers to increase voltage and thus cover greater distances with less loss. However, with the development of power converters, we have been able to have systems that allow converting alternating current into direct current and direct current into alternating current. In this way, the voltage level is no longer a problem. If I needed to work with high direct current voltage, I can start with an alternating wave whose voltage I can increase with a transformer. And then, when it is at high voltage, convert it to high voltage direct current. And this masih very useful because now we would indeed be able to maximize the advantages of each of these two technologies. On one hand, high voltage helps us reduce losses. On the other hand, direct current also contributes to reducing losses because the current flows in a single direction through the cable. The only drawback is that we need to install power converters to make the conversion from alternating to direct current and vice versa. So this type of link will be used whenever the energy savings in direct current transport compensate for the cost of the equipment that allows me to convert to direct current. That is in very long lines. The longer the length, the more resistance. The more resistance, the more losses. And the more losses, the greater the possibility of saving with a technology that minimizes the losses. Therefore, with more savings, the expense of the converters is justified. The more I can save, the more I can spend elsewhere, so that in the end, the whole setup is profitable for me. Thus, we see how what was once a clear victory for alternating current in the war of the currents can today be considered just another anecdote from the past. We can understand how the technological reality of the present and the future must be shaped by combining the advantages of each of the technologies available to us and minimizing their drawbacks. The future is not written only in alternating current, and that is in part the magic of technology, which is capable of reviving to offer us solutions that we were not even able to imagine before. In the next video of this course, we will talk about the different technologies that allow us to extract electrical energy from the resources we have at our disposal to continue delving into the understanding of the electrical systems that drive our world. So don't miss it. See you in the next video.